Hello class, this is chapter 7, section 7.1, the law of sines. So let's see what this is all about. All right, so we have a triangle, it's called an oblique triangle, which are triangles that do not have a right triangle. All right, so usually, or actually all the time, the uppercase letters represent the angles and the lowercase letters represent the sides. And A corresponds to A, they're directly across from each other. B corresponds to B, which is directly across, and C corresponds to C. So whenever you have angle, 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 this triangle cannot be solved. So there's no method that we can use. Whenever you know of an angle and an angle and a side, you can use the law of sines. Whenever you have an angle, side, angle, you can also use the law of sines. When you have side, angle, side, you want to use the law of cosines. Same thing with sine, sine, sine. Side, 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 which we will get to in the next section. And then when you have side, side, angle, you can use either one laws of sine or law of cosines. So let's look at this example here. Well, this is the law of sines, by the way. So in order to find a missing side or a missing angle, you could set up these ratios. Sine of angle A over A is equal to the sine of angle B over B, which is equal to the sine of angle C over C. And you can equivalently write it in this form. It doesn't really matter if you write this one on top or on bottom. As you can see, it's the same thing. It's equivalent. All right, so we have a triangle. Let's go ahead and draw any oblique triangle. It doesn't have to be perfect. I'll label A, B, C. Angle A is 30. Angle B is 70. And side A is 8. Notice that I put A across from A. The letters have to be across from one another. All right, so we need to find the missing side C. So we're looking for this side C. So I'll put that in red. So in order so as you can see, we have angle, angle, side. So that means we can use the law of sines. So I'm going to do this way. First, we need to find the missing angle. Well, if this is 70 and 30, that's 100. That means this has to be 80. All right, so the law of sines says that C over sine of 80 degrees, the side over the corresponding angle is equal to the side over the corresponding angle. You could use these two, or you can use, actually this is the one you want to use because this is what's given to us. 8 over sine of 30. All right, and now we can solve for C by multiplying both sides of the equation by sine of 80. So C is going to equal to 8 sine of 80 over sine of 30. Use your calculators, you will see that this will be 8 sine of 80 divided by sine of 30, which is equal to 15.75. I will round to one decimal place, 15.8. So that is the final answer. All right, let's get to the homework now. All right, so let's skip over to problem number, I'll do question 4. So let's do question 4 here. So I'm going to open up a new page for this. All right, so question 4 says we have a triangle ABC. A is 51. Degrees. Let's see, B is 59. And C is 19. So 19 has to go across from C. So we can find the missing angle by subtracting the sum of those two angles by 180, from 180. So if you do that, you should get 70 degrees. So remember that the angles of a triangle must add up to 180. All right, so they're asking us to find angle C, which we've already done. That's 70. So that one's correct. And then to find side A, that would be this side here. So we can use the law of sines. So the setup would be a over sine of 51 is equal to, so this over the sine of this is equal to this over the sine of this. 19 over sine of 70. All right, once again, to solve, we'd multiply both sides of the equation by sine of 51 degrees to isolate a. All right, and so if we do all that, we're going to get 15.7 is what I'm getting. If I round to one decimal, let's see what they want us to round to. It says round to the nearest whole number, so that would be 16 if we rounded to the nearest whole number. And sure enough, that is correct. So the rest of these problems are basically the same. So I'm going to skip over to some of the harder problems that are the word problems. These three right here are the harder ones. So I'm going to start with this one right here, number 7. A man is flying in a hot air balloon in a straight line at a constant rate of 6 feet per second. So there's your first number, while keeping it at a constant altitude. As he is approaching the parking lot of a market, he notices the angle of depression is 30 degrees. A minute and a half later, after flying directly over his friend's car, he looks back to see his friend getting into the car and observes an angle of depression of 36. At that time, what is the distance between him and his friend? All right, so let's draw a picture of that. So let's see, I'll draw a picture over here. We got a balloon. He's going at 6 feet per second. Angle of depression, and then another angle of depression over here. I think this one was an angle of 30 degrees, this angle of depression. His friend is over here. All right, and then the other angle of depression, once he passes his friend, is 36. So that would be this angle of depression, 36. All right, and it says from this point, so he's going from here to here at a constant altitude, and it takes him a minute and a half. As you can see, the units are in seconds, so a minute and a half is equal to 90 seconds. So to get the distance, we need the distance. The rate times the time equals the distance. So the time is 90 seconds, so you have to multiply 6 times 90 to get the distance. So 6 times 90 is 540. So that's feet. So this is 540 feet, the distance from this starting point to this end point. All right, we can figure out the angle. All right, so the angle would be 180 minus the sum of 30 and 36, which is 114. All right, and then it looks like they want us to find out what is the distance between him and his friend. So that would be this distance right here, which I will call x. All right, and now we can use the law of sines. So x is to sine of 30 as 540 is to the sine of 114. All right, and then we can solve for x by multiplying both sides of the equation by sine of 30. X is going to equal 540 times the sine of 30 divided by sine of 114, which if we do that on our calculators, we should get getting 295.6. Let's see what they want us to round to. Round to the nearest foot, so that would be 296 feet. So it should be 296. Let's see if we're right. And we are. All right, let's look at the next one. A ship is anchored off a long straight shoreline that runs north and south from two observation points 18 miles apart on the shore. The bearings of the ship are N37 east and south 57 degrees east. What is the distance from the ship to each of the observation points? So let's draw a picture for this. Okay, so here is our north-south, west-east. So it looks like there's 2 observation points. We'll put one here. We'll put the other one here. And it says that they are 18 apart. 18 miles, maybe? 18 miles apart. All right. Let's see. And then the ship is 97 N97E. So that would be approximately, maybe we can just call that here, 37. And this one is going to be southeast at 57 degrees. All right, so now we can use our knowledge of geometry. These are parallel lines. This is a transversal, which means alternate interior angles are congruent. So if that's 37, this has to be 37. And similarly, if this is 57, this has to be 57. And we can find this angle by, this is a straight angle, so the sum of these 3 angles has to be 180. So 180 minus the sum of 37 plus 57 is equal to 86. So your goal is always to create an oblique triangle and at least have one side. That's all you need, one side. And now we can find, they want these 2 distances here. So I'm going to call one of them x and the other one y. Let's start with x. So x over the sine of 57 degrees is equal to 18 over the sine of 86 degrees. All right, and then for the other equation, it's going to be y is to the sine of 37 degrees as 18 is to the sine of 86 degrees. All right, we can solve these 2 equations. So isolate the variable. Y will equal to 18 sine 37 divided by sine 86. For this one, I'm getting 10.9 if I round to 1 decimal place. And for the other, I am getting 15.1. So let's see what they want us to round to. They want us to round to 1 decimal place. So for the north one, this would be the north one. That would be our x, 15.1 for this one. And for the south one, it would be 10.9. Oh, I got them backwards. How did I get them reversed? Distance from the northern point. So that would be our x. Okay, so somehow I got those backwards, but just reverse them and you will get those correct. All right, let's look at the next problem. All right, a tightrope walker is standing with 1 foot on the tightrope as shown in the figure. If the tightrope walker weighs 116 pounds, find the magnitude of the tension in the rope toward each end of the rope. Assume that E is 74.5, this angle 74.5, and this angle is 82.5. So what you want to do in these kind of situations where there's like tension or forces, you want to draw the triangle. But then you want to, with these forces, these vectors, you can also draw a parallelogram like that. And so this is our E, let's see, and then you got this line here. So this is our E, and then you want to draw a parallel line. All right, and so these are your 2 parallel lines, and then this is a transversal. So we know that this one is F. F is 82.5. All right, and then the other one is E, right? That would be 74.5. All right, and so let's see here. These 2 are parallel, and then so, whoops, parallel. So we got, let's see, parallel. Okay, so it turns out that since these are parallel, and you got this transversal here, And here, alternate interior angles are congruent. So this one and this one have to be equal. So this is 82.5 here. All right, and then similarly, these two are congruent, and then since this one is equal to this one, and then this one is equal to this one, so this is going to be 74.5. So it's a lot of geometry here. Alternate interior angles are congruent. Then you can find this angle. This is a straight angle. So 180 minus the sum of 82.5 plus 74.5 is 23. So this is 23. Okay, I'll be right there. All right, tell them that I'll be right there.